So today we're going to talk a bit about rational expressions. A fraction is an example of a rational expression where the numerator and the denominator are specific numbers. For example, 3 over 4. When you put that in your calculator, 3 divided by 4 gives you 0.75. Now, if I ask you 3 divided by what will not give you a number, meaning it doesn't really work or doesn't make sense, that number is going to be 0. So 0 is a number that the denominator cannot be. That denominator cannot be a 0. So when we have a rational expression where you have a variable somewhere in the numerator, denominator, or both, what value for x will this rational expression not work? For example, if I say x is equals to, for example, 9, that means you have 5 over 9 minus 8, which equals to 5 over 1, which actually gives you a real number. But what number can you put into x that will not give you a number at the end? Well, we just said that the entire denominator cannot equal to 0. So what number minus 8 will give you 0? That number is going to be 8. Because if you substitute 8 into the expression, you get 8 minus 8, which gives you 5 over 0, which is undefined. Another way to solve for this is you can take the entire denominator and set that or restrict it, meaning not being able to equal to 0. And then you solve it as if it was like a linear equation. Cannot be. Reducing a rational expression. If you have a fraction just with numbers 6 over 8, if I were to ask you to reduce this fraction, you would find a common factor and divide top and bottom by the same value. In this case, you divide top and bottom by 2, and you end up getting 3 over 4. This is called the reduced. Now, when you have variables in a rational expression, let's just say 6x over 8x squared. For example, if I asked you to reduce this, you would reduce the 6 and 8, the coefficients, as we did before, so divide everything by 3 over 4. But then if you notice here, we have an x on the top and we have 2 x's on the bottom. I'm just going to write it in expanded form. And if you notice, x divided by x will give you 1. In other words, you're left with 3 over 4, and you have a leftover x, which is in the denominator. Sometimes I actually teach this when I ask the students, well, how many x's are there in the numerator? There's 1. How many of there are there in the denominator? There's 2. And what's the most you can actually remove from top and bottom? Well, the most you can remove is 1. You can't remove 2 of them because the numerator doesn't have enough. So let's talk a bit about restrictions right now. Well, this rational function has a restriction in the denominator because you have a variable in the denominator. So what value for x would make this entire thing be equal to 0? So let's take the denominator, and you don't want this denominator to equal to 0. So you would solve for this, you divide both sides by 8, and here x times what will give you 0, or you can take the square root, the inverse operation of a square, and you end up getting x cannot be equal to 0. This is your restrictions. When we do restrictions, we always restrict the original denominator before we reduce. So here we have a bit of a more complicated rational expression where the numerator denominator has a degree of 2, a quadratic. To do this, we're going to have to factor. So we have to do trinomial simple factoring, and let's actually review factoring. So to do this here, you need 2 numbers that multiply to 6, but 2 numbers that add to give you negative 5. In this case, we have 3 and 2, negative, negative, negative 3, and negative 2. So simple factoring means you can actually factor the numerator into 2 factors. In this case, it's m, we're using m as a variable, minus 3, and m minus 2. It doesn't really matter which way you write the factors. Over here, I'm not going to explain too much. I'll just go directly into factoring this. You have m plus 5 and m minus 3. Now, if you notice, the numerator and the denominator have a common factor. What that means is you can take m minus 3 and m minus 3 and divide them. Identical term divided by identical term gives you 1. And then you end up with m minus 2 over m plus 5. This is your reduced rational expression. Now let's talk a bit about restrictions. Restrictions should have been done in the beginning. So at the beginning, you're going to look at your denominator. You do not want this denominator to be equal to 0. So we're going to solve for this. So you have m squared plus 2m minus 15 cannot equal to 0. Now to solve for zeros or not zeros, you're going to have to factor this, which we did. And you set each piece factor to not equal to 0. In the quadratics unit, we're used to seeing with the equal sign, but now we don't want it to equal to 0. So m cannot be equal to -5 and m cannot be equal to 3. So these two pieces are your restrictions. As I mentioned before in the previous slide, you always find the restrictions for the original denominator before you reduce. Because if you reduce and you actually find the restrictions for this, it is not enough. You need to cover the entire original function restriction. So I wrote this do not. I've seen many times where students will do the following. So let me just erase this part here. And they do the following. They look at the values of the terms and they see, oh, I see an m squared, I'll just take it out. Oh, I see this, I will reduce it by 3, that gives me 2 over -5, and they have -5m, or they knock out the m and they end up with -5 plus 2 over 2 minus 5, which gives you whatever the answer is, 1 per se. Okay, so please don't do this. Why can you not do this? So let's actually take this and make it numbers. 1 minus 5 plus 6 over 1 plus 2 minus 15. Now there's actually imaginary brackets around here where you do BEDMAS. So you add first, in this case you do all this numerator, you get 2, then you do the denominator, you get 3 minus 4, which gives you -12, which gives you -1 over 6. Now if we did it the wrong way, 1 plus 2 minus 15, oh, 1 divided by 1 is gone, and then this is gone. You're not, I promise you're not going to end up getting -1 over 16. So in this slide, you should pause it and actually try to practice some of these. So to start off with, you should factor as much as you can, find the restriction of the denominator, and then reduce wherever you can. So now's a good time to pause and try out these questions. Okay, so let's factor the numerator. In this case, it's a greatest common factoring. So we have 3x over x minus 1 over here. Now we have 3x. We're going to factor the entire trinomial. That gives us x squared minus 2x plus 1. I can see that this is a quadratic factoring. You're going to have to factor this. Ends up x minus 1, x minus 1. You can put x minus 1 squared if you wanted to. It doesn't really matter. Now, before we start to reduce, we should actually acknowledge our restrictions first. So let's look at the restrictions. In the denominator, there are 3 factors. In this case, we don't want any of these factors to equal to 0. So I'm just showing you my work. I know some students can actually get the restrictions right away. In this case, x cannot be 0, x cannot be 1. We don't have to do this. It's a repeat. It'll give us the same. So these are our restrictions. After you get your restrictions, all right, let's reduce. So I see 3 divided by 3, x divided by x. And now over here, I see x minus 1. I'll see that later. And I have an x minus 1. And what am I left with? I'm left with x minus 1, but that's in the denominator. What's left on top? Well, keep in mind, identical divided by identical terms gives you 1. There is a 1 on top. It's not 0. This one here is going to be the following. We do the very same thing. This is actually a common factor factoring. You have this. You have 4x squared minus 3. All right, this is the most we can factor without having any decimals or radicals. Now let's actually find the restrictions first. Here we got denominator. You don't want any of those pieces to equal to 0. Over here, 4x squared minus 3 cannot equal to 0. This one here, divided by 4, x cannot be 0. So that's our first restrictions. This one here, you do the same thing. You bring things over, and you want to take the square root on both sides. Now, if you take the square root on both sides, keep in mind there are 2 numbers. One's going to be a positive number, and one's going to be a negative number. In this case, you have root 3 over root 4. I'm just going to simplify it further. Square root of 4 is 2. So here is your other restrictions. There's actually 3 restrictions. After this, then you can start to reduce. So gone, 4x, we're left with 1, and then you have 4x squared minus 3.